Hi friends, today we are going to start the other part of the chapter motion, that is of acceleration, and the other part is of graphical representation of motion. Both these parts are very important because one is of acceleration, that is one of the basic concept of motion, like that of displacement and velocity. And while telling about the graphical representation of motion, that is also very important because it is used for the kinematic equation. That is, in the next lecture we will find about what actually the kinematic equations are and also how it to be derived. So for that purpose, graphical representation of motion is very important. So first, let's see what acceleration is. Here, but first of all, students, the acceleration means you are familiar with this word acceleration is, because in vehicle, whether it is a two-wheeler or four-wheeler, you know that there is an accelerator. That accelerator word is very much related to this acceleration. You know that what is the purpose of that accelerator is. Accelerator is in order to accelerate, that is to increase the speed, correct? If we raise it, that is if we give the accelerator, you know that the speed will increase, and when we lose it, you know the speed will decrease. So you know that the change, in order to change the speed, that is change the velocity, what actually the using accelerator is using. So what is acceleration is the same only. So it is related to the change of velocity. Now you know that in physics the most important thing is of time. Everything is of telling depends on the time. Like that of in our life, how the time is valuable. Like that in physics also. It is very important. So here the acceleration, what acceleration is? Acceleration is the rate of change of velocity. So there why we are we are raising, that is why we are increasing the accelerator. What will happen? The velocity will change, we see. So what you are doing is accelerating. So what is acceleration is, look, rate of change of velocity. Understand? Now in physics, what is the rate means? You know. Already in the last class it is told that in physics, whenever you hear rate, you must understand that it is upon time. That is change of velocity upon time. That is what the acceleration is. Sure. So acceleration is what is acceleration? How will you define acceleration? Means it is the rate of change of velocity. Sure. So now what is the change of velocity? Now you know that when we are going in a vehicle, speed is increasing. You can see that in the speedometer. Sometimes it will be at 10 km per hour. Then again while we are accelerating, it will go to the 20 km per hour. Correct? Then again we are accelerating. It will go to the 30 km per hour. Like that. The every time interval. Now the time is also, now normally in vehicle and we don't, now while suppose, we are going to see the time also. For the first 2 minutes, it is in the 10 km per hour. Then after 2 minutes, it is in the 20 km per hour. After 2 minutes, it is in the 30 km per hour. So you know that here the speed is increasing every interval of time. So we can say what is here the change in velocity is what means. Now we see that it is of from 10 km per hour, from 10 kilometer per hour to what it is changed to 20 km per hour. Sure, it is hour. So what is the change in velocity here is 20 minus 10 is the change in velocity. So what actually it is 10 km per hour, you can say. Sure. Now what is the time interval of this change is 2 minutes we are taken. Sure. So what is the acceleration here while telling about? We can say it is 10 upon 2. Okay, 10 upon 2. Okay, that is 5. What it is? Kilometer per minute, because the minute we are taken here. Understand? So it is a kilometer per minute. So that is the acceleration here. Understand, children? So here it is the change in velocity. That means the final velocity minus initial velocity. That is the change in velocity. Okay, so here we can say the formula. Okay, that is here. Okay, this is now one more condition is there. Now the acceleration means there must be a change in velocity. Okay, that is if the velocity is not changing, that is, for example, first 2 minutes it is at 20 kilometer per hour. Second also it is 20 kilometer per hour. Next also it is 20 kilometer per hour. That is whether the speed is increasing, not increasing. At that time you can see the accelerator remain as it is. That is, we are not accelerating. So here the change in velocity is 20 minus 20 is 0. Okay, if the change in velocity, that is 20 minus 20 is 0, then we can say that it is in the uniform motion. Understand it? It is in uniform motion. Okay, but okay, it is not accelerating. Sure, all of you? It is not accelerating, but it is in uniform motion. Sure, what is uniform motion means? Okay, we can say here it is uniform motion. You can see here uniform motion. What is uniform motion means? You must understand that it is V minus U equal to 0. That is the uniform motion is. Sure, understand what is uniform motion? It is the V minus U is equal to 0. Then we can say that it is of uniform motion. Okay, sure, children? Got it well? Now the next case is of, okay, while telling about, okay, next we can say it is of, okay, in the change in velocity. Now the velocity is changing. Okay, any interval of time, that we see the other thing. Okay, then we will say that it is what it is accelerating. Okay, that is different value at a different. Here it is, if it is accelerating means different value at a different instant, that is time. Okay, at a different path point, that is the path will be at the different place. Okay, thus the change in velocity of the object during any time interval is not 0, then we will say that okay, it is what? Accelerating. Some acceleration is there. So acceleration is measure of change in velocity of an object per unit time. That is very important. Sure. So the formula is acceleration is equal to change in velocity upon time taken. Sure. Now here suppose U is that. Now we see that it is the, okay, 10 kilometer per hour, then 20 kilometer. Now the U is of 10 kilometer, V is of 20 kilometer. U is the initial velocity and V is the final velocity. Sure, children? And T is the time interval. Okay. Now we can say that so A is equal to, now A is equal to what it is? V minus U upon T. Okay, that is what the formula. Very important. You must remember this. A is equal to V minus U upon T. Okay. Now here it is. Okay. Then such a motion is what called? What called? Acceleration. Okay. Accelerated motion is called. Okay. Now this acceleration can be negative or it can be positive. Now let's see that when it is of positive, when it is of negative. Now we see it is from 10, then it is 20, from 10 to 20. So here it is the 20 minus 10. Okay, what it is? 10 plus 10. That is positive acceleration. Now suppose the speed is decreasing. Speed is decreasing means initially it was at 30. Then it is changed to 20. Now here what is the final velocity is? 20 is the final velocity. What is the initial velocity is? 30 is the initial velocity. So what is the change in velocity is? Minus 10. So in this case we will say that what it is there? Negative acceleration is there. So acceleration can be positive or negative. Okay, if the change in velocity is positive, that is the speed is increasing, then we will say that the acceleration is positive. If the speed is decreasing, we will say that it is a negative acceleration is there. Now the next is SI unit of acceleration. SI unit of acceleration is, okay, meter per second square. What it is? How will you read it? Meter per second square. Okay, now in order to write it easily, we will write it as meter, okay, into second raised to minus 2. Okay, it means while you are reading, how will you read it is meter per Okay, per means upon. Meter per, what it is, second square. Okay, like this you have to read. Meter per second square. Sure. So that is about the acceleration. Okay, so what we see here, the uniform motion, that is v minus u is equal to 0, then uniform motion is there. If there is no uniform motion, then there is acceleration is there. Now acceleration means what it is, okay, there is a value, that is v minus u will be a value, some value will be there. Okay, that is not equal to 0. If we like that, we can say, okay, if v minus u is not equal to 0, then we can say that some acceleration is there. Sure. So acceleration is equal to change in velocity upon time, that is a is equal to v minus u upon t. V is the final velocity, u is the initial velocity upon the time taken. Now next is the unit of acceleration is meter per second square. Okay, so now the next is okay, we can say uniform acceleration. Now we are talking about the acceleration. Now what is the uniform acceleration? Now one case, that is uniform motion we see. What is uniform motion? V minus u is equal to 0. It is uniform motion. Now other case is there, that is for an equal interval of time, v minus u is equal to a constant it is. What it is? A constant. Okay, if v minus u is equal to a constant, okay, for equal interval of time, then we will say that is a uniform acceleration. So understand, that is for example, now the it is like this, for every 2 minutes, okay, every 2 minutes, okay, every 2 minutes, okay, it is like the first it is of 10, okay, afterwards it is 20, afterwards it is 30, afterwards it is 40, it is like this. Now look, in this case, now what is the time interval here? 10. What is the interval here? 10. That is change in velocity v minus u. Okay, 10. What is the interval here? 10. Look, every 2 minutes, what is that? It is 10 it is. Sure. So we will say that in equal interval of time, the equal, okay, the change in velocity is also equal. So we will say that what it is there, uniform acceleration is there. So look here, what the definition is. Okay, velocity increases or decreases by, that is the we can change, we can say. Okay, velocity changes, okay, by equal amounts in equal interval of time, then the acceleration of the object is said to be uniform. Sure, all of you? Okay, now the next case. Now every 2 minutes, now I am going to tell it is of first it was 10, okay, then it was 20, then it was 40, then it was 50. Okay, it is going like this. Now look, first interval it is of 10, okay, second interval it is of 20, again next interval it is of 10. Now look here, whether it is in equal interval of time, equal, the change in velocity is equal, not equal. That is, if this, okay, v, okay, minus u is not equal to a constant, okay, not equal to a constant, then we will say that uniform acceleration. That is, the change in velocity is, okay, unequal amount. It is unequal amount, okay, in equal interval of time, then we will say that uniform acceleration is there. Sure, children, it is very important. Okay, I hope you understand. Distinguish also can be asked. Distinguish between uniform acceleration and non-uniform acceleration. Now, the example of uniform acceleration. You know that freely falling body. Freely falling body, it is due to the acceleration due to gravity. It is of falling down. Okay, such a free fall is always uniform acceleration is there. Okay, now the next is non-uniform acceleration is, okay, we are moving in a car. Okay, the normally what it is there, uniform, non-uniform acceleration is there. Sure. So that was the, okay, acceleration part is. Now let us move to the graphical representation of the motion. Now already I told that because it is very important because of okay, further, that is for especially of equation of motion, it is very necessary. Okay, now what is the other importance of graphical motion? You know that it is easy to understand. For example, even, okay, you are very familiar and interested in cricket. In cricket, you know that in between the graphs are shown. What is the purpose is so that easily we can understand that how the changes are. Okay, but while it is showing the numbers, it won't be very easy to understand. But while seeing the graph, we know this order, okay, scored much, this order scored less. Okay, like that, okay, it is easy to understand. Okay, so that the graphical representation is always easy for the, okay, understanding. Okay, so here the first is of the distance time graph. Now listen students, now here one thing, in a time graph, that is in the graphical representation of motion, okay, time is always taken in x-axis. That is very important. That is, time is taken always in x-axis. Now the distance, velocity, etc. will be taken on y-axis. That is the other thing. In the distance time graph, the distance is taken along the y-axis and the time is taken along the x-axis. Sure. Now the different, okay, uniform motion is there, non-uniform motion is there, etc. will be there. Now here the example of a motion is given here. Now look here, every okay, second, okay, in every 1 second, the distance covered in meter is given here. See, okay, you can see here it is correct. Okay, different time it is given. Now okay, now here we can say that, now suppose this is, I am going to give, okay, this as T1, okay, this as T2, okay, and again this as S2 and this as S1, this point as S1, okay. Now here we can give this as A, okay, B and C, okay. Now here this is, now look, AB, distance AB, this triangle you are seeing, this triangle, okay, in this triangle, okay, AB is there, okay. Now how we can find the AB means T2, what is T2? 10 is T2, what is T1? 5 is T1. So AB is equal to, what it is? AB is equal to T2 minus T1, sure, T2 minus T1, that is what you will get, it is of 5 seconds, okay. Next is of, what it is next? BC. Sure, next is BC. Now what is BC is? BC we can say that, now instead of in the same point T2 I am given S1 also. Okay, now it is S2 minus S1. What is now what is S2? S2 is of 40. Understand? Minus what is S1 is? S1 is of 20. Sure. So which is equal to, what is 20 minus 40 minus 20 is, you know that is of 20. Sure, all of you children. Now look here, this we can say the slope. Okay, what is slope? Okay, slope or gradient means here the, okay, base, in this case the base upon what it is height, that is the slope. Okay, otherwise we can say it is of, in slope the formula is y2 minus y1 upon, okay, yeah, this x2 minus x1. Okay, in this case what actually it is T2, sorry, not T2, it is of yeah, y2, this is y na, yes, y2, in the place of y2 what it is there, okay, let me erase this, it is not there, okay, so that it is of, okay, so it is of what it is, S2 minus S1 upon T2 minus T1. Okay, now what is S2 minus S1? S2 minus S1, you know that it is of BC. Okay, what is okay, T2 minus T1, you know that it is of AB. Sure, all of you? Okay, so which is equal to, what is BC? BC is of 20. Okay, what is AB? That is time, that is of 4. Sure, so 20 upon 4, that is 5. It is, we can say, now it is meter and upon divided by second meter. So what actually it is? So this slope is nothing but it is the velocity. Like that we will get the velocity. Sure, children? Like that we can use graph in order to find the, okay, velocity. Distance time graph will be used to find the velocity. So this is the case. Okay, now how the uniform speed is? Now here you can see that, okay, different graphs are given here. Okay, children, listen here. Okay, now here uniform speed. Okay, now if the uniform speed, you can see, you will get a, what you will get? A straight line. Understand? So that anywhere you take the triangle like that of here, you will get equal the slope is. The slope is remain same in any instant the slope will be same. Now this is the non-uniform. In the non-uniform case, you will get a curve like this. Okay, now in the case of the curve, okay, now you different place you take the slope, so it will be different. Understand? Now it is a stationary. Stationary means the object is at rest. If it is rest, it will be parallel to x-axis. Sure, because time is changing, velocity distance is not changing, so it is called at rest. Sure, all of you. So this is about the distance time graph. Okay, now the next we will move to the other, that is velocity time graph. Now the velocity time graph is very important. Already we see that, okay, that time is always taken on x-axis and velocity is taken on the y-axis. Sure, all of you. So here in the first case is, but this graph is represent, it is represent the uniform motion. Now uniform motion means you have to remember that v minus u is equal to 0. That is no change in the velocity. Now you can see, okay, after 1 it is of 40, after 2 it is of 40, after 3 hour it is of 40. So every time it is, so v minus 2 is 0 here, that is 40 minus 40 is 0 here. So here it is like that. Okay, good children. So this case, this is the velocity time graph for the uniform motion. But it is uniform motion. So it is straight line will come parallel to the, okay, time, that is of x-axis. Now what you can do is, in this case, in order to find the displacement or the distance traveled, what you can do, okay, you draw a perpendicular from any point to the y-axis other point, so that in between you will get a rectangle. Sure, you got a rectangle. Okay, in this rectangle, okay, whatever, now what is there? Here it is the time, correct? Okay, what is here? Here it is the velocity. Okay, now velocity means you know that is the distance upon time is the velocity into, okay, the time. Though time is cancelled, what is displacement you will get. So we can say that here the displacement S is equal to what it is here, area of, okay, yeah, it is here area of the rectangle, what it is, area of the rectangle ABDC. Sure, all of you. Okay, now so that here it is area of a rectangle ABCD. What it is, how you can find it is of AC. Look here, height is AC, that is the basis of CD. Okay, that is length into breadth. The length is of CD and okay, breadth is of AC. So that CD, AC into CD. Sure, all of you children? Okay, now what is AC? AC, you know that it is T2 minus T1. Okay, what is AC? AC is whatever the velocity, it is the 40 is the, it is there. So that like that we can find here. Sure, so it is the case of the, what it is, uniform motion. Okay, now so this area, look here, this mentioned area enclosed by the velocity time graph axis will be equal to the magnitude of the displacement. Like that we can, okay, using velocity time graph we can find the displacement. Sure. Now we will go to the next, that is of a uniformly accelerated motion. Okay, in this case here, okay, uniformly accelerated motion. Uniformly accelerated motion, okay, what we can see is the nature of the graph, okay, it will be, it is how it is will be, it will be straight, okay, line. Okay, you can see there in the side, okay, there you can see that, okay, now it is, now there only we see that the slope will be, in this case you take the slope at any interval of time, it will be remain same only. So in this case, okay, how we can find the acceleration? Okay, how we can find the, okay, this, okay, here it is, yeah, what I told is slope. Okay, anywhere you take the slope. Now what is the slope in this case? Now look here, this, you are getting a triangle is seen. Okay, in this triangle, okay, you can see that again, what is the slope? What is the slope means? Slope means here in this case it is of y means here it is, okay, this is the vertical, this is y and this is x. Okay, so that it is of ED, okay, upon this is of AD, correct? Okay, that is the slope. Now ED means what it is? Velocity, that is change in velocity, not velocity exactly, change in velocity. And here it is okay, change in, that is time interval, that is t. What is v upon t? So that is nothing but the acceleration. Understand? So that the slope here, whatever the slope we are getting, that is the acceleration. Sure, all of you? Now here it is, okay, now we are going to again, we are going to take, now again we are going to take the area, any point, okay, the between the 2 point on the line and that of the x-axis. Okay, any area you can take this much also. Understand? Now whatever the area covered in that part will be the displacement. Understand? So here you can see that. Okay, A, B, C. Look here. A, B, C, D, E. This much part. You are seeing? Okay, that is what? That only, nothing but that is also the displacement. Sure, area is the displacement. Now this is how we can find it. Okay, you can find that on triangle is there and other one rectangle is there. So area of this triangle plus area of this rectangle. Okay, that is what the area here. Sure. So that here look, area of the rectangle ABCD plus area of the triangle AD. Now what is the area of the rectangle ABCD? Area of the rectangle ABCD is equal to AB. Okay, what it is? AB into BC. Getting AB into BC plus a half of AD into DC. Sure, children? So that is here. Okay. Now this here you can in this table you can find that how the uniform acceleration is there. Look, every it is 5 second, 10, 15 equal interval of time, that is 5 seconds. Here what is the change in velocity? 9. Here also 9. Here also 9. That is 9. Okay, kilometer per hour is the V minus. Okay, here in this case V minus U. What is V minus U is 9 kilometer per hour. Understand? So that it is what it is? Uniformly accelerated motion. Sure, all of you? Now the next is of that is non-uniform motion. Non-uniform motion means it is changing. Okay, this is so in the case of the non-uniform motion, it can be like this. Understand? So it is decreasing. Okay, so in this case the slope may not be same. Okay, here it is varying at any interval of time. Understand? So these are the two graph of the non-uniform acceleration, that is the velocity is not uniform. Understand? So that is the graph we forgot. Understand, all of you? Now while this graph you are seeing, which graph, this graph actually represent what? It is the negative acceleration, you can say. Okay, this is, there is no, the anyhow it is, sometimes it is high, sometimes it is low, again accelerated. Okay, so like that it is continuously changing in this case. Okay, it is so these two graph represent the non-uniformly accelerated motion. Sure, children? So that is what here. Okay, here it is a velocity time graph represent the motion object whose velocity is decreasing. Look, that is I told that the negative. Okay, and here it is the varying. Okay, anyhow it is varying. So that is about it. So I hope you understand it very well. Okay, you have to practice it. You have to read the textbook. Okay, then only you can understand the concept. And there is you require a lot of imagination. Okay, so we studied about the acceleration. That is what is acceleration? Rate of change of rate of change of velocity. Okay, that is rate of change of velocity is acceleration. Okay, so acceleration A is equal to V minus U upon T. Okay, unit is meter per second square. Sure, all of you? Okay, then we studied about the time graph. Now uniform acceleration we studied. Okay, that is if V minus U is equal to 0, then it is uniform motion. Okay, you must understand that. Okay, V minus U is equal to 0. Okay, understand? V minus U is equal to 0, then it is uniform motion. Understand? It is motion. Okay, then if it is V minus U is equal to a constant value, then what it is? Then it is a uniform, uniform acceleration. Sure? Okay, now V minus U is not equal to a constant. Okay, then what it is? Then we will say that the motion is what? Non-uniform acceleration. This much things we studied, and the graph also you understand. In graph you must have to understand that displacement, velocity, etc. will be taken on y-axis, and time is always taken on x-axis. And the slope, in the distance time graph, slope represent the speed. In the velocity time graph, the slope represent the acceleration. Okay, again the area under the graph, that is area under the line that is graph line, and that of the x-axis represent the displacement. That will be very useful for the equation. That is what we are going to use in the kinematic equation. So thank you very much, children. Have a nice day.